What is up, Algebra 1? This is lesson 98. Our objective is, how do you solve quadratics by factoring? So, a quick challenge here for you. Find two numbers, a and b, such that whenever you multiply a and b, you get 0, but a and b cannot equal to 0. So you have a $1 prize if you can figure out two numbers, a and b, such that whenever you multiply them, you get 0, but neither of those numbers are 0 themselves. Pause this video. Figure it out. Go. I'm being serious. Pause the video and try it. Okay, good. Now that you have listened to me and you have tried for hours on end possibly, and you may have found out that you haven't been able to figure anything out. And that's because of this, the zero product property. It says that if the product of two quantities equals 0, meaning if I multiply two numbers and they equal 0, at least one of the quantities must equal 0. So either a is equal to 0 or b is equal to 0. One of them must equal to 0. Alright, so having that in mind, notice I have something here. Something times something is equal to 0. So since it's something times something is equal to 0, as I'm trying to solve that, I know either x minus 3 is equal to 0 or x plus 8 is equal to 0. Well, those are easy enough to solve. I'll just add 3. So I get x is equal to 3, or I end up with, well, if I subtract 8, I end up with x is equal to negative 8. So if I wanted to write it properly, I'd say negative 8 is a possible answer, and 3 is a possible answer. Those are my answer set of all my answers. So either of those would make that statement true. If I plugged negative 8 in here and here, this expression would come out to be true, because right here, negative 8 plus 8, that would be 0, times negative 11, doesn't matter what that comes out to be. 0 times a number is going to give me 0. If I plugged 3 into this one becomes 0, because 3 minus 3 is 0. Doesn't matter what this comes out to be. 0 times any number comes out to be 0, so this would be true. So these are all of my answers that would make that expression true. Now, this one was already factored for us, but we're not always so lucky. Look at part B. It doesn't have something times something, but I can make it that way because I notice that both of these terms have an x in them. So I can pull the x out and I get x times x plus 2 is equal to 0. So now I do have something. I have something times something is equal to 0. So that means one of those somethings must equal to 0. So I can say either x is equal to 0 or x plus 2 is equal to 0. Well, that one's easy enough to solve because it already says x equals 0. Here, if I subtract 2, I end up with x is equal to negative 2. So again, my solution set would be negative 2 and 0. Or my two answers that if I plugged into this expression would equal to 0. Now as we move to part C, we notice that it doesn't equal to 0. So I want to get it equal to 0 so that way I can apply my zero product property. So I'm going to go ahead and subtract 19x from both sides. And I will end up with 7x squared minus 19x minus 6 is equal to 0. So let's see about factoring this. I need to find factors of 6 combined with factors of 7 that will subtract to give me 19. Product of these is 6 minus 7 gives me negative 1. It's going to give me 1 minus 6 times 7. That's way bigger than 19. That's going to give me 3 minus 14. That's going to give me 11. This is going to give me 2 minus 21, which gives me that 19. So this is a combination that I need. So this is going to be x and 7x. It's going to give me 3 and 2. I need the 3 to be negative and the 2 to be positive. So they're going to give me a negative. So again, notice that I have something times something is equal to 0. And if I have something times something equals to 0, then I can say one of those must equal to 0. So x minus 3 is equal to 0. Or 7x plus 2 is equal to 0. Solving this, add 3 to both sides. You get x is equal to 3. Or, solving this, subtract 2. 7x is equal to negative 2, dividing by 7. X is equal to negative 2/7. So then my solution set is going to be negative 2 over 7, or 3. Alright, one more I'm going to try to squeeze in here. This one, again, it's not equal to 0, so I want to get it equal to 0. I'm going to take everything to the right-hand side. So I'm going to add 2x squared. And I'm going to subtract 20. So I'm going to add 2x squared and subtract 20. So I end up with 0 is equal to 2x squared, that's that one, minus 20x plus 50. Now I'm noticing that they all have a factor of 2 in there, so I can factor that out. That means 0 is equal to 2 times x squared minus 10x plus 25. Which gives me 0 is equal to 2 times factors of 25 that add up to 10. It's going to be x and x, 5 and 5, and they're going to both need to be negative. So now in this case, notice I actually have 3 things. This is equal to 0, this multiplied by this multiplied by this. 3 things multiplying. So then I can say either 2 is equal to 0, x minus 5 is equal to 0, or x minus 5 is equal to 0. Well, notice 2 cannot equal to 0, so that's not an option. But x minus 5 could equal 0, right, if I added 5 to both sides. So that means x could equal to 5. And the same thing actually if I do this, add 5 to both sides. So x is equal to 5. So in this case, I just have one answer. That answer is 5. Because 2 cannot equal to 0. And those two answers come out to be the same. So my answer for this one is just x is equal to 5. Your homework is on page 659. You can do the lesson practice, all the 98s and all the 97s. And then that's it. Good luck, guys.